Hello, and welcome on this dark evening to Laing's Trains. Just thought I'd have a little intro tonight by showing my new station lights. Hence why it's dark. Like them? Lovely. Anyway, I would now like to talk about YouTube Studio and analytics. See, if cameraman would like to come in here and zoom over. Zoom in. Now, does one notice, appears according to this, that all my viewers are over 55 or 65 and entirely male. I know this is lies because I know that I've got some subscribers and viewers that are younger and even a couple of females. I shall now like to redress this issue. Okay, so before we start this carry on, I want to show you a freak thing that happened. I accidentally installed this train working on the catenary line the wrong way around. So it shouldn't work at all. But, you just have to take my word on it here. Power on the catenary line only. What is powering that? And why is that working? Answer following soon. So, kids, get off your X station box thingy, switch, whatever it is, and get to school. In fact, never mind school. Didn't do this guy's much writing skills any good. But you can skip the physics lesson. And you won't need to go to physics because you can subscribe to Laing's Trains and ring the bell and leave a comment. Okay, kids? There now follows a serious physics lesson. And you at the back, stay still, stop fidgeting. Stop it. Right. So, to answer this question, why did those trains move? We have to go into the world of physics and atomic particles. So, kids, everything, stuff is made of atoms. And atoms are really quite wee. So, atoms are made of stuff as well. And they are stuff called protrains, okay? Protrains. And neutrains. Neutrains. Okay? And little thingies called electrains. Right. Now, protrains are quite big. Like this. Okay? And they're really quite positive in their attitude towards life. They like life and let's go do things and life's great. Neutrains, they're really boring. They're like those static models you get. They don't really do anything. So we're just going to forget about them because they're boring. What's really interesting is electrons. So they have a bit of a negative attitude towards life. They're like, that's not right, we should do this, and that's not right. But they tend to like protrains. So protrains are very positive. Electrons are a bit negative. And these like to hang about them and go whee, whizzing round. Okay? Now, they sit still, they make stuff, and these things move. And therefore, these things actually, even though they're a bit negative, make the world go round. Okay, stop. So, in the world of model railways, we have a controller. And it has a plus side and a negative side. Now, as I said before, these negative guys like the plus side, but they're not directly connected. And I don't know how this makes this negative that positive. I don't care. So what happens is it goes along a rail, it goes through a train, and they want to come back here. right? Woo! And while it goes through the train, there's a motor in there, and that's what makes the train move. Okay. So, in my lovely catenary thing, normally that is a rail and that is a rail, okay? And the wheels sit on there. But on my catenary thing, what happens is, let's just say, that is not a rail, that is the wire. And it goes through the pantograph, right? Like that. Aha! So, if the wheels on this side are on the wrong side, it can't work. Okay? It cannot work. So why did that train that I showed you at the start, the wee shunter, it's not connected to the pantograph, go that way, put wheels in it, and the one with the pantograph go that way when this was connected, but these wheels weren't connected because they were on the other rail. Have you been paying attention, kids? Adults too. You've been paying attention, because this had me stumped for a while. I shall now reveal the secret. And then the first person to comment can win this tree. Okay. So, to recap, once again, here are the two trains. They're not actually coupled because they're both missing couplings. And catenary power only, go. And stop. And reverse, catenary power only. Yeah, just got that in the shot there. Stop. Right, I know you're dying to know. You're dying to know. Because this train has no power. I should say the other side of the catenary is on this inside rail. So power from the wire to the inside rail. That is deliberately back to front. So it has no pickup from this inside rail. Has none. You just have to believe me. So why is that moving? Here's a clue. Okay, I removed this engine. Turn the power on, Mr. Assistant. Power on? Power on? Yep, power on. Nothing happens. Put the train back on. Goes. Reverse it in again. Yep. Reverse it in again. And stop. Right. I know, you can't take it anymore. Here's the answer, okay? The power goes through this wire. Now, it can't go to that rail. But it really wants to, because remember, kids, it wants to get back to... Let's call this the negative. It wants to get back to this, the positive, okay? But it can't, because the wheels on this side are not connected. They are connected on the other side, but that isn't. So here's the answer. After months and months of your research, and I think I won the Nobel Prize for this, for physics. It goes in there, it goes through there, it goes through the motor, it goes through the wrong rail, because the wrong wheels are connected to that rail. It goes through the wheels, outside wheels on this train, and back through the motor on that train, and connects to the inside rail, and the wee electrons go way all the way home to Mr. Proton. And that's how they go the wrong way. Thank you. Thank you for watching. Get it to life. Get to school. Get to Laing's trains. Yo!